A very good morning, students. We have started the very most important chapter, limit. And after the introduction, I discussed mainly the two type of sums to solve on limits. What the two type of sums I discussed last day? Direct substitution, sums on factorization or rationalization. Though only few sums I taught, but this type of sums also will be discussed afterwards, or in the study material you will get a lot of sums. Now you see, today what I have taken here, some standard limits. So many standard limits directly we have to use to solve the sums on limits. You see the first one, and one thing, all the formula, all the standard limit, like limit x tends to a x to the power n minus a to the power n by x minus a, directly will use the result n into a to the power n minus 1. Derivation of this formula very interesting, though the derivation of all the formula is beyond of your exam viewpoint. But this theorem proof, after binomial theorem, you will be able to understand. So I am not going to discuss this one now. After binomial theorem, because a concept about binomial theorem like a plus x whole to the power n or 1 plus x whole to the power n, the result will be needed for the proof. That's why I'm not going to, this is the important theorem or as well as the derivation of this formula. Not only that, another important one is this one. You see, limit x tends to 0, sin x by x, directly instead of this kind of figure, sin variable whole by some variable, provided the variable tends to 0, also we will write equal to 1. This proof by 2-3 methods we can do. Either taking the area of sector we can do, or there is another very good method, but which is now not in all of you for the syllabus. What? The series of sin x. This formula also, like a to the power logarithm function, exponential function, also there is the series of logarithm and the exponential. These are all nowadays out of syllabus. That's why this direct standard limit to only the result when you are getting the same figure. You see the last one, limit x tends to 0, log of 1 by x whole by x equal to 1. Limit x tends to exponential function. Last two you see logarithm and exponential function. Another function for the logarithm, limit x tends to 0, a to the power x minus 1 whole by x equal to log a base e. But you don't have idea about logarithm function. When this type of examples will be taught, the logarithm properties I will discuss. I think it is clear. Now let us start the application of the sum of the standard formula today. Like, see the first result, limit x tends to a x to the power n minus a to the power n whole by x minus a equal to n into a to the power n minus 1. Our second formula, limit n tends to infinity 1 by x, directly we will write 0, and this one you know. Actually when x tends to 0, sin x 0, limit x tends to 0, cos x equal to 1. These are two very simple. These two also application. So out of so many formula in the exercise for the sum, you have to apply number 1 a, number 2 b, and number 1 b also. But these are very simple. Number c very much important. Number c and d, and in some number in the serial number 3. All the three as application we will get as a sum. So today, few of them I am going to discuss. Say a sum is, you see the first standard formula. For limit, generally you will get the question, evaluate. Say our first question is limit, and what the first question I am taking here, the same sum last day you have done by factorization method, today directly using the standard formula, you see the same sum what you have done last day, x square minus 4 divided by x minus 2. Last day what we have done by factorization, x plus 2 into x minus 2, x minus 2, x minus 2 cancel, writing the reason as x tends to 2, x not equal to 2. On the remaining part, you substitute the value x equal to what? 2. Answer was 4. Now, directly by, you see this one, last day you have done at least 2-3 steps. Today, using the formula, directly in second or third step, you are getting the answer. How? Compare this with the given, with our standard formula, limit x tends to a, you see a value is 2, yeah, x square minus 2 square whole by x minus 2. So, a value, compare a value to n value to, answer is n into a to the power n minus 1. So answer is 2 into 2 to the power 1 is also coming 4. I think it is clear. So directly using the standard formula, last day what type of this type of sum we have done by factorization, today by standard formula we are getting the answer very quickly. Now this type of one more example, just in opposite way, try to clear. So sum is given if limit x tends to 2 x to the power n minus 2 to the power n by x minus 2 equal to 80. Find the value of n. I repeat, the question is, if x to the power n, just the value given, n value not given, using the standard formula, by solving, we want to get the value of n. Now, see, what is the formula for this one? X to the power n minus a to the power n by x minus a. Formula is n is unknown, into a to the power 2 to the power n minus 1 must be equal to 80. Now, from here, how to solve n? Try to clear. 80. We know 80, very simple, 16 into 5. So after that, what we can write, you see, 5 into this one, 16 is 2 to the power 4. Not only that, we can write 5 into 2 to the power 5 minus 1. This is also 80. So I am writing as left side is in like this figure. That's why to compare both the sides, or to compare the like terms from both sides, we are breaking 80 like this. So 2 into n minus 1 equal to 5 into 2 to the power 5 minus 1. This one is also 80. Compare both sides, you are getting n equal to 5. Or if you take the power, n minus 1 equal to 4, n equal to 5. Very simple. So today, one application, out of some standard limits, the application of the first one is this. You see, the second one, I have given the formula what? Very simple formula, limit x tends to infinity 1 by x equal to 0. This is our standard limit. What type of sum you will get for the application? Say question number 1. A simple sum I am taking, limit x tends to infinity 3x cube minus 2x square plus 4x plus 1 divided by x cube plus x square minus 2x plus 3. Very, very important and short question also. What you will do, you see, in the numerator and denominator, both are polynomial function. The highest power x cube, generally when x tends to infinity and both numerator and denominator contains the polynomial function, generally you will divide both numerator and denominator by the highest power of x, that is here is x cube. So we are dividing both numerator and denominator by x cube mentally. X cube by x cube is 1. Yeah, minus 2 into x square by x cube is this. And here plus 4 into 1 by x square and here 1 by x cube. Try to clear. We have divided the numerator by x cube. Similarly, if we divide the denominator by x cube, we are getting 1 plus 1 by x minus 2 by x square plus 3 by x cube. Now, you see, when limit, and you know the property, when plus minus into division, limit will be distributed with all the function individually. That's why limit x tends to infinity 1 by x, our formula is answer is 0. You see, if I use so 1 by x, this part with the limit, the answer will be 0 because 2 into 1 by x, yeah, 4 into 1 by x whole square is also 0. This one is 1 by x whole cube is also 0. So this part 0, this part 0, this one will be 0, this one also will be 0, this is 0, this is also 0. So finally, if I use the limit, what is left? Answer is 3 by 1 is 3. In bracket, you can give the reason as limit x tends to infinity 1 by x equal to 0. So in these 6 places, we have used the formula to get the answer. Very simple application. Now, on this one, we are going to do one more sum for this. Try to clear. Say a sum is given. Limit x tends to infinity root over x square plus 7x minus say x. A very, very important question, and not only that, this is a simple question. So you see, root over figure, generally what we are used to do from lower classes, you know, just rationalize the numerator by its conjugate number, you multiply root over x square plus 7x plus x. Here is also x square plus 7x plus x. Numerator and denominator both are multiplied by the conjugate of this one. That's it, this rationalization you know. Last day also you have done. Now in the numerator, after this one, what you are getting? Limit x tends to infinity, same a minus b into a plus b, direct formula, square root over cancel minus b square divided by this one, same root over x square plus 7x and minus x. Yeah, x square cancel. Now one important calculation is there. What is the calculation? Try to clear. That is equal to limit n tends to infinity. There is 7x divided by, here we are taking actually inside the root over, you are taking x square common. So if I take x square common inside the root over, x square means you know x, we are writing only x. So here what is left? 1 plus 7x by x square means you are getting 7 by x, and there is minus, this one is plus x, I'm sorry, this was plus x, and you are dividing this one, what? This one, if I give this one x first times n. Now again, this x and this x, if I take common, limit x tends to infinity, same, this one 7x, same, from denominator x and x, if I take common, then what is left? Root over 1 plus 7 by x and plus 1. Again x cancel, the reason you know, as x tends to or simply you divide it as x tends to infinity, x not equals to 0, that's why you are going to cancel. And after that, or mentally you can do it, after that use the limit, you know, when the limit x tends to infinity, 1 by x is 0, so final answer 7 by, this cancel, 7 by root over 1 plus 0 plus 1, final answer 7 by 2. I think it is clear. Now, today the application of two standard formula I have discussed. Most important formula will be the third one. What is the third one? Today just I am starting, but on this formula there are so many type of sums we have to face one by one. Today one by one I will discuss. Today only few I am going to discuss. Number one, what is the standard formula? Limit x tends to 0, like sin x whole by x is also 1. The formula is also for tan. Limit x tends to 0, tan x whole by x is also 1. At first I have copied. Application of this. First simple sum, evaluate. Question number 1. It is given limit x tends to 0. Say the question is sine of 5x whole by x. With a very simple example, try to clear. Now, our formula, you see, this one, and this one. All the three should be the same type of variable. But here is 5x, there is x, here is also x. What we are doing? We are multiplying numerator 5, and to balance it, you are multiplying in the denominator also 5. So finally you see these two are coming same. Not only that, in the AR should be also 5x, but that one you can write as a reason what? As x tends to 0, 5 into x also will be tends to 0. That's why we are getting for this one the answer is 1 and the 5 is same. Answer is finally 5. I think it is clear. Second example, number 2. Say limit x tends to 0. Here is given, say sin 3x divided by tan of 5x. Just one more question. What you will do? Again what we are doing, I am doing only there, or in the newest step you can do. To get the standard figure, limit x tends to 0 same, you see sin 3x same as that, here tan 5x also same as that. Formula, sin x whole by xm figure we want, here nothing is given, we are dividing here by 3x. To balance it, this 3 I am writing 3 here, x I will divide here 5x we need, that's why divided by 5 into 5 is there, and say you see numerator and denominator both are divided by x, so x is already balanced. After that you see this one is our standard formula, this one is also our standard formula. What? The answer is 1 into 3 by 1 into 5. But be careful, you have to write the reason. The reason already I told you, because here is only x. That should be for this one 3x, and this should be for this one 5x. What we know, as x tends to 0, 3x also will be tends to 0 and 5x also will be tends to 0. Reason always to write, not only answer. So finally the answer is 3 by 5.